is one of the very important and most important chapters from 12th class chemistry, and that is electrochemistry. What is electrochemistry? Generally, most of the students get fear about physical chemistry because physical chemistry includes many formulae, numericals, and some difficult topics. Actually, physical chemistry is most interesting if you can understand, right? Let's first see what is electrochemistry. What's the meaning of electrochemistry? Electrochemistry is a study of production of electricity from energy released during spontaneous chemical reactions. We'll go very slowly, no need to rush during our explanation. You try to understand the meaning of electrochemistry. What is electrochemistry? It's a branch of chemistry and is study about the production of electricity from the energy released during the spontaneous chemical reaction. That means during chemical reactions, some chemical energy will be released. That chemical energy is converted into electricity. Okay, this is one way of definition. And also the use of electrical energy to bring about chemical transformation. That means we can use electrical energy to bring about some chemical transformation, means chemical reactions. Means both will be happen. That means production of electricity from chemical reactions, as well as by using electricity we can perform chemical reactions. So this is called simply about electrochemistry. So if you cannot understand this definition, no worry. And in the coming during our discussion, you can easily understand. Here, one more simplest explanation you can see. Chemical reaction can be used to produce electrical energy. Chemical reactions can be used to produce electrical energy. Conversely, electrical energy can be used to carry out chemical reactions. This is about electrochemistry. That means like electrochemistry is going to study about that interconversion of chemical energy into electrical energy and vice versa. That means electrical energy into chemical transformations. Right. Now, first
Yes, sir.
we'll start with what are the main applications of electrochemistry. First, if you see batteries, fuel cells, which converts chemical energy into electrical energy. We use batteries in our daily life very intensively, means in almost all electronic devices, in a TV remote controls and mobile batteries and all. So here you can see two pictures. This is a mobile battery and this one is a fuel cell. Okay. Okay. See here, electrochemistry is an important for creating new technologies that are eco-friendly. You know that batteries nowadays, you can see some electric vehicles, EVs, we can say, electric motorcycles, electric cars, and even electric buses we can see in the cities. So these are all eco-friendly because they produce very less pollution in comparison with petrochemicals. So these are all happen due to the advancements of electrochemistry. Now, the transformation of sensory signals through cells to brain, vice versa, and communication between the cells are known to have electrochemical origin. That means, suppose what is meant by transmission of sensory signals? Suppose if you touch something, you feel the touch. If you touch ice, you feel coldness. If you touch some hot object and you feel hotness, that means through your sensory organs, you feel that hotness or coldness. That means the sense of touch, that signal can reach to brain through some sensory signals. This is also, this communication between the cells are also due to some electrochemical origin. That means electrochemistry is a very vast and interdisciplinary subject. That means it is not only belong to chemistry or physics, it also belong to biology. That means it is an interdisciplinary subject. And in this unit, we will cover only some of the important elementary aspects of electrochemistry. Okay, first we'll start with electrochemical cells. This is the first and most important part of electrochemistry. And here we are going to discuss what are electrochemicals, chemical cells, and how they work, and what are their applications briefly. Okay, electrochemical cells. And this
So,
definition also important for you for your board exams. Right? First, we'll see what are electrochemical. A device, what is electrochemical cell? A device which converts chemical energy from spontaneous redox reactions into electrical energy is called electrochemical cell. Just for simplicity, I just change the definition like this. It is a device which converts chemical energy into electrical energy. That's all. You remember up to this. So what is the electrochemical cell? It is a device which converts chemical energy into electrical energy. From where we get this electrical energy? Generally, during chemical reactions, particularly redox reactions. Do you know what are redox reactions? Redox reactions means it includes two words, reduction and oxidation. It's a combination of two words, reduction and oxidation. During redox reactions, some chemical energy will be produced. That chemical energy is converted into electrical energy. That is the function of electrochemical cells. I hope you understood what are electrochemical cells. Electrochemical cells are the devices which converts chemical energy into electrical energy during spontaneous redox reactions. And these are also called galvanic cells or voltaic cells.
yes, sir.
One second. So this is a diagrammatic representation of a galvanic cell, and we are going to discuss about this electrochemical cell and its arrangement and its working and what are the chemical reactions taking place in galvanic cell or electrochemical cell in our continuation. See here, it's a device. In this device, the Gibbs energy of spontaneous redox reaction is converted into electrical energy. What is a electrochemical cell? It is a device which converts chemical energy into electrical energy. So here one more word you got Gibbs energy. What is Gibbs energy? You might have studied about Gibbs energy in the chapter thermodynamics in your 11th class, junior intermediate. So Gibbs energy is a free energy of a system, and that we'll discuss later in thermodynamics. So actually, you no need to worry about this Gibbs energy and all. You just remember that some energy, chemical energy, during a spontaneous redox reaction converted into electrical energy. So for Gibbs energy, this is a formula. If you know about this formula, okay, no problem. If you don't know, also no problem. See here, delta G is equal to minus NFE. So we'll discuss about this formula in the coming classes. Delta G, here delta for change, G for Gibbs energy. Actually, this is a change in Gibbs energy or Gibbs free energy. So do you know what is Gibbs free energy? I will, to just make you understand, I'll give one small example. Myself having some energy internally, I have some internal energy. So out of my internal energy, I am using some of my energy to take you this class. What I am doing now, right now, I am teaching a chapter, that is I am teaching electrochemistry. For this purpose, I need to utilize some of my energy now. I have some energy,
Yes,
say for example, just to make you understand, I have some 100 kilojoules of energy. Just for a understandability purpose, I'm taking this example. I have some 100 kilojoules of energy. Out of my 100 kilojoules of energy, I'm using 2 kilojoules of energy for this teaching purpose. This 2 kilojoules of energy is called Gibbs energy. Means the energy, the useful energy to the energy of a system to do some useful work. Energy of a system to do some useful work. So how out of 100 kilojoules, 2 kilojoules of energy I am using for this class. So this is called Gibbs energy. Okay. These are little bit difficult topics, and actually these topics you will get in thermodynamics. If you don't know, no need to worry. Just you keep on listening and try to understand. If you get any unknown things, you just take a notes of it. Delta G is Gibbs free energy. N is number of moles of electrons. Number of moles of electrons. and F is Faraday's constant, and we will discuss about Faraday's constant also in the coming classes. And finally, E is a standard cell potential. Actually, it is enough E naught. Okay, no problem. E is a standard cell potential. So this is a small formula. Later also we'll discuss about this formula. Now, what are the uses of electrochemical cells? Actually, electrochemical cells have many applications like in batteries, portable powers, dry cells, alkaline batteries like electronics and electric vehicles, lead storage batteries like car batteries. In our homes, we have inverters. If power shut off suddenly, and then we'll have inverters at our homes, and medical devices like pacemakers, hearing aids, corrosion protections like sacrificial anodes for ships and pipelines, and many other fuel cells, sensors, analysis, and emergency power, and industrials and space. Many applications are there. So in all these devices, we use electrochemical cells, and these electrochemical cells produces some chemical energy, and that chemical energy is converted to electrical energy by these cells. Now, briefly we'll discuss how these cells works and what is the chemical reactions taking place in electrochemical cells. For this was simplest example I'll take. This is the simplest example for electrochemical cell. This is the reaction you can see here. You note down this reaction. Zn, zinc, which is in solid state. That means this is a zinc rod plus Cu plus 2 aqueous solution. Aqueous solution of copper. Copper salt solution. Cu plus 2 gives a Zn plus 2 plus Cu. So this is a redox reaction. Okay, I will discuss about this reaction in detail in this class itself. So first you note down this reaction. Zn plus Cu plus 2 gives Zn plus 2 plus Cu. Right? Here zinc oxidation state. What is the oxidation state of zinc here? Nothing is
Zero,
there.
sir.
0. Oxidation state of copper in the reactant side plus 2. But in the
Plus two,
product side, zinc oxidation state plus 2 means zinc oxidation state changes from 0 to plus 2. That means it is oxidation. Zinc is undergoing oxidation. Oxidation state of copper is plus 2, but here oxidation state of copper is 0. So plus 2 to 0. That means copper is undergoing reduction. You please mute
reduction.
please mute. And whenever I ask, please unmute yourself. And these reactions occur in two different portions of the Daniell cell. Actually, here we have seen two reactions. One is oxidation reaction and another one is a redox reaction. So these two reactions takes place in two different portions in the Daniell cell or galvanic cell. So the reduction half cell occurs. Okay, I will come to this part later. First, you go through this picture. Yeah. This is the simplest arrangement of galvanic cell, construction of galvanic cell. And here you can find two beakers. The first beaker is filled with some blue colored solution. Actually, it's not blue. Just for what to say, identification, we have mentioned this. Actually, it should not be like this. It should be this one copper in which we have taken this copper. No, this should be in blue color, and this should be colorless. Okay, don't be confused. Okay, don't confuse about these colors. Just you remember that whatever the electrode or this beaker we have taken in the left side is a zinc sulfate solution, and this one is zinc rod. Zinc rod is dipped in zinc sulfate solution. Copper rod, this is a copper rod. Copper rod is dipped in copper sulfate solution. Right? Now, these are the two half cells, and this is a voltmeter, and this one is switch. Okay, this in between these two beakers, there is a U-shaped arrangement. This is a U-shape. See this one, U-shaped arrangement. This is called a salt bridge. So this is the simplest arrangement of galvanic cell. So what are the things are there in this arrangement? We have taken two beakers. The first beaker is filled with zinc sulfate solution. Actually, this is zinc sulfate solution, and this one is a zinc rod. This is copper sulfate solution, and this one is copper rod. And these two solutions are connected with a U-shaped arrangement, glass rod. This is called salt bridge. And these two electrodes, zinc rod and copper rod, these two are connected with some external wire. This is external wire. Say for example, some iron or any metallic conductor. It's a metallic wire, and in between we have arranged one voltmeter to know the how many voltage of current is produced there. And this is a switch. This is the simplest arrangement, right? Next, what are the reactions taking place in galvanic cell? Actually, in galvanic cell, two reactions takes place. As I said already, reduction reaction and oxidation reaction. Actually, reduction reaction takes place at cathode, this part where copper is dipped in copper sulfate solution. Oxidation takes place at anode, where zinc rod dipped in zinc sulfate solution. Right? That's what we are going to see here. Reduction half reaction. So Cu plus 2 electrons gives Cu. What is reduction? Reduction means gain of electrons. Gain of electrons. Because of the gain of electrons, oxidation state will be reduced. Here copper oxidation state plus 2, and when it gains 2 electrons, it will be neutralized. This plus 2 and 2 electrons are minus 2, plus 2 and minus 2 both cancel, and this becomes neutral, Cu. So here oxidation state of copper is 0. So this is called reduction. Here oxidation state is plus 2, here 0. Reduction means reduce. I think you know the meaning of reduce. Reduce means becoming less. Right. Next, oxidation half reaction. Oxidation means just reverse to this. Here zinc metal loses 2 electrons, becomes Zn plus 2. Here oxidation state of zinc is 0. It loses 2 electrons and becomes Zn plus 2. Here 0 to plus 2. Increase in oxidation state. This increase in oxidation state is called oxidation. So this one is oxidation half reaction. Actually, this reduction half reaction takes place at cathode. Oxidation half reaction takes place at anode. This is how the working process. There is a tendency of metal ions from the solution to get deposited on the metal electrode, trying to make it positively charged. At the same time, metal atoms of electrode have the tendency to go into the solution and make it negatively charged. You may not understand this, so just I will make you understand by taking a small 1 second. So I'll try to understand. I'll try to make you understand. See here. So this is the two solutions we have taken. This one is zinc sulfate solution, for example, and this one is copper sulfate solution, CuSO4. And in zinc sulfate solution, we have placed one zinc rod. This is zinc rod. In copper sulfate solution, we have placed copper rod. Both are connected with an external wire. In between, we have kept one voltmeter, right? And here, one U-shaped salt bridge we placed. Let's see what is the process of this oxidation and reduction reactions. Here you can see this zinc rod, no? This zinc rod, solid zinc rod, this one. This zinc rod loses 2 electrons. Zinc rod loses 2 electrons. Zinc rod means a zinc rod consists of a huge number of zinc atoms. The zinc atoms loses electrons and becomes Zn plus 2. And this Zn plus 2, see this is a zinc rod now. Here from here, zinc metal atoms come into the solution in the form of Zn plus 2. So these are aqueous zinc ions. That means here oxidation reaction is taking place. Where oxidation is taking place? Here at anode. This is anode. And conversely, in the cathode, here what happens? Here this is a copper sulfate solution. This copper sulfate solution consists of a huge number of Cu plus 2 and SO4 minus 2 ions. Copper sulfate solution. This is aqueous solution of copper sulfate. It consists of a huge number of copper ions. These copper ions move towards copper rod. Copper ions move towards copper rod. And from there, they get 2 electrons. This copper ions get 2 electrons. I'll write here. Cu plus 2 plus 2 electrons gives Cu. You may get one small doubt. Sir, from where these 2 electrons are coming? From where these 2 electrons are coming? Actually, here zinc is losing 2 electrons now. Zinc metal atoms losing 2 electrons converted to Zn plus 2 ions. These Zn plus 2 ions entering into the solution. That means this solution is getting more number of Zn plus 2 ions. What about these 2 electrons? These electrons move from this external wire towards the copper. Now, these electrons, 2 electrons move towards copper. There what happening? These copper ions which are present in the solution, copper ions present in the solution gets 2 electrons. You have to understand from where these 2 electrons are coming. These electrons are coming from the zinc rod. So here, whatever the electrons lost by the zinc, and these electrons traveling through this external circuit and entering into the copper rod, and from there where the copper ions are getting accumulated over the surface of copper rod here. So here simply the Cu plus 2 ions gets 2 electrons becomes Cu. So this is how the process actually takes place, and this is called a redox reaction. This one is reduction. This is reduction. Reduction takes place at cathode, and oxidation takes place at anode. Okay. So this is simply, and now you try to understand. See here, there is a tendency of metal ions. Here metal ions means Zn plus 2 ions or Cu plus 2 ions from the solution to get deposited on the metal electrode, trying to make it positively charged. Right? This statement related to whatever I say here, this one. Cu plus 2 ions getting accumulated over the surface of this copper rod, and this copper rod obviously becomes positively charged. Here, this towards anode what happens? Zinc metal atoms entering into the solution by leaving 2 electrons. These 2 electrons will move. These 2 electrons will move from this external wire. That means what is the charge of this anode here? The charge of the anode is negative because it is giving out electrons now. Due to these electrons, the anode becomes negatively charged. And these electrons move towards cathode, which is positively charged. Simply you remember anode is negatively charged due to the electrons released by the metal atom and metal atoms, and cathode is positively charged due to the accumulation of the cations over the surface of cathode. If you don't understand this explanation, you no need to worry. Just you keep on listening. All these things you are not going to write in your exam. Just for the conceptual understanding only, I am explaining this. Otherwise, you no need to worry about this process. Right? Next, this is the part where happened at anode. At the same time, metal atoms, here metal atoms means zinc atoms of electrode, have the tendency to go into the solution. Zinc metal atoms go into the solution and make the metal rod negatively charged. Right, we'll continue. Okay. Okay, this part, okay, no need. See here, whatever the explanation we had now once again we will discuss. So this is a zinc sulfate solution. The zinc nitrate solution is taken here, no problem. Zinc nitrate, copper nitrate, whatever it may be, zinc salt solution, copper salt solution. This is zinc salt solution, and this is zinc rod, and it is negatively charged. Minus is mentioned. Why minus? Why minus? Zinc is losing 2 electrons now. So those 2 electrons move through this external wire. So this part will be more with negative charge. So zinc electrode is mentioned with the negative charge. So copper cathode is a positively charged due to the accumulation of copper ions over the metal surface. So this is a salt bridge. Here this salt bridge is filled with sodium nitrate gel, NaNO3 gel, and to neutralize both the solutions, both anodic compartment and cathodic compartment. Actually, here what happens when zinc ions are entering into the solution, here there will be electrical imbalance. So there will be more negative and less positive charges. Here there will be no more positive and less negative charges. Like this, there will be imbalance in the charges. To balance the charges, this sodium nitrate will neutralize both the solutions, that is cathodic solution as well as anodic solution. Now see here, electrons are moving from anode to cathode. Electrons are moving from anode to cathode, right? This NaNO3 becomes Na plus NO3 minus, and these ions move towards respective electrolytic solutions to make them neutral. So this is how galvanic cell works. Actually, what happens here, during this redox reaction, some chemical energy will be produced. That chemical energy will be converted into electrical energy by the galvanic cell. Here the flow of electrons will be from anode to cathode, from zinc rod to and copper rod. But flow of electron will be reverse. Sorry, flow of current will be reverse. Current will flow from copper rod to, that is cathode to anode. This is the direction of moving electrons from anode to cathode, but current will move from cathode to anode. So just you remember. Okay, this process will take place as long as there will be balance in this charges of both cathodic and anodic cells. So actually, when you use a zinc salt solution and copper salt solution, the voltage will be in the voltmeter. In this voltmeter, the voltage will be 1.1 volts. What is the voltage? 1.1 volts, 1.10 we can say. That is the voltage produced during the galvanic cell of zinc sulfate and copper sulfate, or zinc nitrate or copper nitrate solution. You remember this value. What is the electrode potential or voltage due to the connection between zinc sulfate and the copper sulfate solution in a galvanic cell? The voltage will be 1.1 volts. Okay, and these are all the points I have taken from your textbook itself. Suppose if the voltage is if the external, here we have what we have done, the same arrangement. Here some external potential we are going to apply. See this arrangement. This is external potential. We are applying some external potential slowly. We are increasing the potential slowly. Then what happens, we will see. Now this class will be ended within some 6 minutes. After the end of the class, again you rejoin, and okay, that's enough. Okay, after this class, you rejoin again, and the class will be over. Just a few more slides are left. Later, from tomorrow, not tomorrow, day after tomorrow onwards, I'll try to take regular classes based on the availability of time, most probably in evening time. See here, if external opposite potential is applied in the galvanic cell and increase it slowly, what happens? See, in the case 1, when external voltage, see here, external voltage is less than 1.1 volt. Why we have taken 1.1 volt? This is the actual voltage produced during the galvanic cell arrangement. When you take zinc sulfate or zinc nitrate, copper nitrate solutions, then this is the actual voltage produced. Then electrons flow from zinc rod to copper rod. Hence, current flows from copper to zinc. I said all these points. Okay, if you don't know, note it down. Otherwise, if you have textbooks, underline these points. Important. If external voltage is less than 1.1 volts, then electron flows from zinc to copper. Current flows from copper to zinc. See here, these arrow marks represents the flow of electrons. This arrow mark represents the flow of electricity. Next, let's come to the case 2. In case 2, if the external voltage, whatever the voltage we are applying here, is equal to 1.1 volt, then no flow of electrons takes place. That means no chemical reaction, no current will be produced. That means the external voltage we are applying will be equal to the voltage produced during the redox process. If both are same, then there will be no flow of electrons. The potential difference becomes zero. No chemical reaction, no current will be produced. This is case 2. Suppose in case 3, when the external potential is greater than 1.1 volts, that means we are applying more than 1.1 volt of voltage externally, then the reverse takes place. Reverse means what? Reverse to the first case. What happened in the first case? When the external potential is less than 1.1 volts, electrons flow from zinc to copper, current flows from copper to zinc. But in the case 3, when external potential is greater than 1.1 volts, electron flows from copper to zinc, current flows from zinc to copper. Okay, these are the 3 cases. You have to remember these 3 cases are very, very important. This is one of the important part. You can take this screenshot of this, and otherwise in your notebook, in your textbook, so clearly mentioned, you underline all these points under that 3 different diagrams given. So in the figure 2.2a, 2.2b, 2.2c, here I have mentioned only 2.2a, but 3 cases I have explained, right? Just 2 minutes left. So we'll see. Number of galvanic cells can be constructed on the same pattern of a Daniell cell by taking combination of any 2 different half cells. Generally, just what we have used a zinc rod, zinc sulfate solution, copper rod and copper sulfate solution, isn't it? We no need to take zinc sulfate, copper sulfate every time. You can change these metal electrodes, and you can create a number of galvanic cells with the different combinations of different half cells. So that's the meaning of that. Just look at 2 multiple choice questions are given here. You try to answer. A cell in which electric current is produced by oxidation reduction process is called what? What is the name of the cell which produces electricity by oxidation reduction process? Whether it is voltaic cell, reversible cell, concentration cell, or standard cell?
Voltaic cell.
Voltaic cell. Here voltaic cell, Daniell cell, galvanic cell, all are same. You don't confuse. Okay. So voltaic cell or a Daniell cell converts chemical energy into electrical energy. And the function of salt bridge in an electrochemical cell. We have discussed about salt bridge, which is a U-shaped arrangement. The salt bridge is a very important, and its functions also very important. And we have not discussed in detail about this. You can take the screenshot of this question. So these are the 3 functions of salt bridge. All the 3 are correct. What is
Yes,
the
sir.
function of a salt bridge? Salt bridge prevent the mixing of electrolyte in 2 half cells. That means cathodic half cell and anodic half cell. It prevents the mixing of electrolytes. And second one, it completes the circuit. If salt bridge is not there, there will be no flow of current. No electricity will be produced. So it completes the circuit. Next, to maintain electrical neutrality. I told you already, salt bridge, the whatever the salt we take there, sodium nitrate and any other potassium nitrate, it maintains electrical neutrality. So all the above are correct. Okay, you please rejoin the class and we'll continue. Few more slides are left. Okay.
Yes, sir.
Next, Daniell cell is shown as Daniell cell representation. How Daniell cell or galvanic cell is represented? Actually, this topic we have not discussed, and now we are going to discuss about the representation of galvanic cell or Daniell cell. So here some chemical representation is given, and this representation also very important. In most of the competitive exams, representation of different Daniell cells is asking. So now let's see how to represent a galvanic cell or voltaic cell. And for this, we have some IUPAC convention. What is IUPAC? IUPAC means International Union of Pure and Applied Chemistry. So according to this union, and there are some certain rules. Based on those rules, we are going to represent galvanic cell. Because why representation of galvanic cell is important? Representation of galvanic cell is important because every time we cannot draw the diagram of anodic cell, cathodic cell, salt bridge, everything we cannot draw now. So instead of that, representing in terms of symbols is easy, and moreover we can save a lot of time. So how to represent galvanic cell by IUPAC convention? See, write anode on left hand side and cathode on right hand side by putting a vertical line between a symbol of the metal and the metal formula of the electrolyte in the solution. Metal and the formula of electrolyte in the solution. So I will write and show you how to represent the galvanic cell. First we have to write anode on left side, cathode on right side. Okay. See here. So in the previous representation, anode is this zinc, no? Anode is zinc, cathode is copper. Zinc rod is dipped in zinc sulfate solution. Here you have to understand few terminology. Here this zinc rod is called zinc electrode. These electrodes are anodes or cathodes. Okay. Zinc is anode. This is called electrode. Copper is cathode. This is also electrode. Two electrodes are there, zinc and copper. Zinc rod is dipped in zinc sulfate solution. This solution is called electrolyte. Copper rod is dipped in copper sulfate solution. This copper sulfate is called electrolyte. So two terms, electrodes and electrolytes, you should understand. Electrolytes. Electrodes are the metal rods, those are zinc and copper, and electrolytes are the aqueous solutions. These are aqueous solutions. So we have taken zinc sulfate solution and copper sulfate solution. That is the meaning of electrode and electrolytes. So here we have taken two electrodes and two electrolytes. See here, zinc rod is dipped in zinc sulfate solution. No, first this is a cathode. No, sorry, anode. No, this should be written in at left side. So now I am going to write zinc rod dipped in zinc sulfate solution, ZnSO4 solution. So between these two, we have to draw a vertical line. This is zinc rod, this is in solid state. Zinc sulfate solution is an aqueous solution. We have to mention like this. Next, second part, copper. Sorry, 1 second. Next, copper rod is dipped in copper sulfate solution. This is cathode. Cathode is written on, this is LHS, this is RHS, right hand side, right hand side. So here this representation is just opposite to this. Here zinc rod is dipped in zinc sulfate solution and a copper rod is dipped in copper sulfate solution. This is how we have to represent. And next, between these two representations, two parallel vertical lines should be mentioned. This is the complete representation of galvanic cell. Complete representation of galvanic cell. Okay. Instead of drawing this diagram every time, And just simply, if you write like this, we can understand which one is anode, which one is cathode, just by seeing this representation. So from this representation, what we can understand, zinc rod is dipped in zinc sulfate solution, copper rod is dipped in copper sulfate solution. And put a double vertical line in between the solution, just we discussed. And once again, you see here, anode, this cathode. Between anode and cathode, there is a parallel vertical lines, two parallel vertical lines. And how we have to represent? First, we have to write metal followed by electrolyte. And between metal and electrolyte, there is a vertical line. And this is anodic part. And here in cathodic part, from right side, we have to first write metal and then electrolyte. Otherwise, you can remember like this, RP. RP means reactant to product, right? Here R represents reactant, P represents product. For example, we'll take the same reaction, whatever we're discussing now. Zinc loses 2 electrons, becomes Zn plus 2. Copper gains 2 electrons, becomes copper, Cu. And cell representation, Zn bar Zn plus 2. This is the first representation, anodic representation. And between zinc metal rod and zinc sulfate solution, there is a vertical line. And then CuSO4 solution contains Cu plus 2 ions, and in which copper rod is dipped. So this is, these two are separated by one more vertical line. Actually, this anodic compartment and cathodic compartment both are separated by two parallel vertical lines. Okay, it's no need to confuse. It's a very simple thing. See here, this is the representation, no? Galvanic cell representation. Once again, quickly I will go, because I am stressing on the same topic again and again, because these are the very basic concepts. My intention is to make you understand. Okay, let it take some time, no problem. See here, these are the two electrodes we have taken. And here zinc sulfate solution. This is copper sulfate solution, CuSO4 solution. Zinc rod, copper rod, both are connected with the external wire. Here there is a salt bridge. This is how we have represented. This is zinc rod, this is copper rod. Now I'll write this. See, first what I am going to write? First I have to write zinc, then zinc sulfate. Then here salt bridge is there, no? The salt bridge is represented with two parallel vertical lines. Okay, zinc rod and zinc sulfate solution, these two are separated by one vertical line. Similarly, zinc rod, zinc sulfate solution, salt bridge will be represented by two parallel vertical lines, then copper sulfate and copper. See, zinc metal rod, zinc sulfate, salt bridge, copper sulfate, copper. Now I am going to write, see, Zn bar Zn plus ZnSO4. Okay, this part is over. Now salt bridge, two parallel vertical lines, then copper sulfate, CuSO4, then copper bar Cu. This is the representation. Or this can be simply written as Zn bar Zn plus 2. Zn plus 2, why? Here Zn plus 2, SO4 minus 2 ions will be there. Two parallel vertical lines. Then Cu plus 2, because Cu plus 2 ions will be there, bar Cu. So this is the simple representation of galvanic cell. Whenever you find this representation, you have to understand that, and this part is the anodic part, this part is cathodic part. Here oxidation is taking place by losing electrons. Here reduction is taking place by gaining electrons. That's all, very simple. And by this, I hope you understood about this representation and all, cell representation. So next we'll move. Write the cell reaction taking place in the cell. Here one cell is given. We have to write cell reaction taking place here. Okay. Shall you try? What is the cell reaction? Shall you try? Okay. I'll try to explain you. So first note down the reaction, Cu bar Cu plus 2 and Ag plus bar Ag. Okay. Cu bar Cu plus 2, double arrow, sorry, parallel vertical lines, Ag plus bar Ag. So now we have to write reaction for this. First one is this one. This is anodic part. Cu converted to Cu plus 2. See, Cu converted to Cu plus 2. This is anodic part. Here oxidation takes place by losing 2 electrons. This is different. The previous one is different. This is our question. We have to answer this. So Cu loses 2 electrons, becomes Cu plus 2. And this part is over. What about this one? Ag plus becomes Ag. Ag plus becomes Ag. How it can be possible? Ag plus becomes Ag means it has to gain electron, no? By gaining 1 electron. Ag plus gains 1 electron, becomes Ag. This is similar to our previous question. Zn gives Zn plus 2 by losing 2 electrons. Cu plus 2 gains 2 electrons, becomes Cu. Okay? Here the thing is
Yes.
different. Cu converted to Cu plus 2. Cu converted to Cu plus 2 by losing 2 electrons. Ag converted to Ag. Ag plus converted to Ag by gaining 1 electron. But the thing is, here the number of electrons should be same. Number of electrons. Here 2 electrons are there, no? Here also there should be 2 electrons. That means we have to take 2 moles of Ag. 2 Ag plus 2 electrons, 2 Ag. Now, if you want to get the complete reaction, let's cancel the electrons. Here 2 electrons, these 2 electrons get cancelled. Then reactant side copper is there. So let's write copper plus 2 Ag plus gives the product side Cu plus 2 is there. Let's write Cu plus 2 plus 2 Ag. This is the overall reaction. Okay. This is first time, so you may be a little bit confused, or you may feel difficulty in understanding this. No problem. Such type of reactions, many will come in the future discussions. So by that time you will become perfect. But you should have the what to say, you should have tendency to learn. Okay, don't give up, and you struggle yourself and try to understand. And if you don't understand, you can ask me now itself. I'll explain one more time, no problem. So now let's give this answer. I already given you. So this is the complete cell reaction. How the cell reaction can be written, and I have explained you with the some other slide, this one, so you can understand. EMF of the cell. EMF means electromotive force. EMF means electromotive force of cell. That is cell potential, we can say simply. Okay. Electromotive force or EMF of cell is calculated. Write down this formula. EMF of cell can be calculated by
Yes.
using this formula. Cell potential is equal to E right minus E left. What is E right minus E left? Okay, right side potential minus left side potential. Right side potential means cathodic potential. That means the potential of this part, and left side means the potential of anodic potential. First, you write down the formula. Later in the coming classes, you will understand what I am saying. Okay, so this is the discussion for this first class of electrochemistry. And actually the concepts we discussed are very little, but repeatedly the same concept we have again and again discussed. That's why the class took very long time. Okay, why I have stressed on different parts again and again, because these are the very fundamentals and very important, because if you don't understand these parts clearly, you cannot able to answer the questions, objective questions that you are going to answer in your competitive exams like NEET, IIT, JEE, or any other state level competitive exams. So on a whole, at the end, what we have discussed here, very simple. What are the topics we discussed here? We discussed we have discussed about galvanic cell. What is galvanic cell? Galvanic cell is a device which converts uh, chemical energy into electrical energy during a redox process. So which galvanic cell we have taken? For example, we have taken a zinc sulfate and copper sulfate. Zinc sulfate, copper sulfate galvanic cell we have taken, in which zinc rod is undergoing oxidation by losing 2 electrons. Okay, copper gets reduced by gaining 2 electrons. Okay, the overall reaction will be 2 electrons get cancelled. So Zn plus Cu plus 2 gives Zn plus 2 plus Cu. So this is the overall reaction. This overall reaction is represented by IUPAC rules. IUPAC, as per IUPAC representation, this can be represented as the first part is represented as Zn bar Zn plus 2, and there is a salt bridge between these two. So two vertical parallel lines, then Cu plus 2 bar Cu. So how we have to understand this? This is anodic part, this is cathodic part, or this is left hand side, this is the right hand side part. Okay, here oxidation takes place, here reduction takes place. So all these points we have to remember. And finally we have come across one formula: EMF of cell, electromotive force of cell, is equal to electrode potential of RHS, right hand side, means this part, and cathodic part, electrode potential of right hand side potential minus potential of LHS, this minus this, that we have to take. Otherwise there is one more simple representation. This is my personal formula: EMF of cell is equal to E higher value minus E lower value. Higher value minus lower value gives the EMF of the cell. Whatever some values will be given in your exam, so you find out which is the higher value, which is lower value. You just subtract lower value from higher value, you will get the EMF of the cell, and that we'll discuss in detail in the coming classes. So dear students, that's it for today. And I think myself that I took a lot of time, and you also patiently listen the class.
Yes, sir.
Okay. And once while listening the class, you just take the notes of it, and later you go through your textbook and you will be perfect. And if you get any doubts in between, and you can ask in the next class, or you can ask me in our WhatsApp group.
Yes.
Okay. And then I'll try to answer in my free time. Okay. Moreover, these classes are being recorded, so that later, if any further doubts and all, you can go through these video recordings once again. And one small request for all of you is just like the videos whatever I am uploading in my YouTube channel, because these videos will be reached to many students who are in need, and it improves the subscription count also. That one small help you do. And this is not actually, these are not paid classes, these are completely free classes. And my intention is to make this platform a very big platform. That's why I would like to take classes in English. Actually, initially I have started these classes in Telugu, but yesterday only I decided that however I am taking the classes, let me continue in English, so that it will be helpful for many other students from other states also. Okay. Thank you. We'll meet in the next class, probably day after tomorrow. Okay. I will tell you the time and everything. I will share the details and all in my WhatsApp group. Okay. See you. Bye.